Hello friends, welcome to CEC live lectures. I am Dr. Pavitra Bharadwaj. I am Associate Professor in the Department of Computer Science in Jesus and Mary College, University of Delhi. So friends, we are talking about data mining in this series of lectures, and today will be the 11th lecture. This will be the 11th lecture in the series. So far we have covered a lot of topics related to the basics of data mining, the introduction, the techniques which are used, how data is pre-processed, what are the different tools and techniques which are required for pre-processing of the data. So now we have arrived at a stage where we have a certain input data set which is ready to be used in the algorithm for data mining. And therefore now onwards we are going to look at the different types of analysis techniques which are actually used in the data mining. So first and foremost technique, which is a very simple technique which is known as classification analysis, is used for analyzing or for classifying the data or the data set, right? Now, as this is a very inherent tendency in human beings, that whenever we see a group of information or a group of objects, we tend to divide them into classes, or we tend to group them into different categories, right? Like for example, if we have our emails, right? So in case of email also, what we will do, we will group the email as spam and not spam email, right? Or say for example, if we go in the realm of medical science, so medical science will also try to classify the different diseases, or they will try to classify the different kinds of tumors, like malignant tumors or benign tumors. Likewise, in all the domains of knowledge, we see that classification is very commonly done. Now when we are looking at a simple data set or a very limited number of objects which have got very simple attributes or limited number of attributes also, then we can do a manual classification. That's not a problem. But what we are looking at in this scenario is that we are looking at huge data sets which have got hundreds of attributes. So in such a case manual classification techniques cannot be used, and what we are going to use will be an automated solution, an algorithm driven solution to the whole exercise of classifying the data or classifying the objects which are represented in the data set. So if we look at this simple classification task, so this model, it's a very basic simple model which is represented here, and we say that we have an attribute set X, and this, when it goes through the classification model, it is going to give a label to that instance which is having that attribute set X. A label will be given, it will be classified as class Y. So basically if you look at it, it's like a mathematical model we are looking at. It is an abstract kind of model, and if we try to look at it in more practical and in more in a more sort of relevant kind of easy to understand way, we can say that in a data set, if we are looking at a data set which is say in a tabular format, right? So we know that there are multiple instances of objects, right? And each instance will have a set of attributes. Say the set of attribute is referred to as X, right? Now according to the attributes, according to the properties of the attribute, the object or that instance can be classified and given a class label which will be Y. So it is actually the attributes of the instance which are going to give the classification, or which is going to identify the class, okay? So the data for a classification task will actually consist of a collection of instances, or what we also call as records, right? And each instance is characterized by the tuple X, Y, right? So I just explained X is the set of attribute values that describe the instance, and Y is the class label of that instance. So Y is the class label of that instance which has been determined with the help of the attribute. So the attribute set X, it can contain attributes of any type, while the class label Y is always a categorical class, right? So attributes could be numeric, attributes could be, textual, attributes can have any values, right? But the class is always going to be a categorical type of attribute, because you are defining the range, or you are defining the group to which that particular instance is belonging to, right? So classification model is an abstract representation of the relationship between the attribute set and the class label, right? So the model, it can be represented in many ways, like we will be also looking at how different classification schemes work. So it can be represented in the form of a tree, in the form of a probability table, it can be represented in the form of a vector of real valued parameters. There can be many ways in which the classification model can be represented, but at the end of it, the relationship between the attribute set and the class label is represented through a classification model, right? So the classification model is actually a target function f that takes an input, the attribute set x, and produces an output corresponding to the predicted class label, which is y, right? So what are we saying? We are applying a function f to the attribute set x, and the function results, or the function gives a value of y. Okay, so then this model is said to classify an instance xy correctly if fx is equal to y, right? So now this table very clearly gives us the example. Like for example, we look at the task of filtering the spam email, right? Now the attribute set can have any features which are extracted from the email message, okay, like the header or the content, through which we can classify whether the mail is a spam email or it is a non-spam email. Likewise, if tumor identification is done, right? So there are several features which are extracted from the MRI image scans of the tumor, and looking at those features of the MRI scan, those attributes of the tumor which are given through the scan, we can classify the tumor as malignant or benign. Likewise, even galaxies can be classified. Now galaxies are also classified based on the images which are obtained using the telescope. So galaxy classification also, you can have different types of galaxies, like elliptical galaxy or a spiral galaxy or an irregular shaped galaxies, right? So you can have multiple types of attributes, and using those attributes you apply them to the classification function, and in result you get the class label for that particular attribute. Now it is also important to understand that in certain cases, like we were taking the example of spam filtering or tumor identification, right? Here you only have two classes, right? Either it is spam or it is non-spam, either it is malignant or it is benign. So it is got only two values, right? So so this kind of classification problems where we have only two possible values or only two possible classes, these are known as binary classification problem, right? Whereas the classification problem of a galaxy, where you have multiple classes like elliptical, spiral, irregular shape, then that is known as a multi-class classification problem, because the function has to return multiple classes. It can have n number of classes where n can be greater than equal to 2, whereas in binary n is always equal to 2. That is, either the object will belong to one class or it will belong to the other class, right? So now in order to study this classification problems, we take interesting examples are given in the text, right? So if we look at one of the very common examples, so one example which is used to understand the classification problem is the vertebrate classification problem. That is how animals, vertebrate animals are classified looking at the different attributes of their body, like body temperature, skin color, whether they give birth to young ones or not, whether they are aquatic, whether they can fly, whether they have legs, or they hibernate. And looking at these attributes, the type or the class of the mammal can be given. That is, whether it is mammal, whether it is reptile, it is fish, it is a bird, it's an amphibian, different type of classes can be given looking at these attributes. So this is the classification problem of the vertebrates. Right. Another classification problem example that we see is the home loan borrower or the loan borrower classification problem, in which we have some personal information about the borrower, okay, whether he is a homeowner, what is the marital status, what is the annual income, and looking at this information, looking at these attributes of the borrower, we can determine, the algorithm will determine whether the borrower will be a defaulter or whether the borrower will not be a defaulter. So either it will be yes or it will be no. Now we have to understand that in vertebrate classification problem, it is actually a multi-class problem, because it can give you multiple results. It can give you fish, it can give you amphibian, it can give you mammal, non-mammal, like this, right? But the same problem of the vertebrate classification can be used as a binary problem, classification problem also, if you only try to categorize the animals or the vertebrates as mammal and non-mammal. So then in non-mammal, all fish, birds, amphibian, reptiles, etc. will come, and the other animals will come as mammals. So the idea is that the same classification problem can be used to classify, to make it into a multi-class problem or to show a binary class problem, right? So a classification model, basically it serves two very important purposes. The first purpose is that it can be used as a predictive model. Predictive model means that if you have an unlabeled instance, right, so then you can use the classification model to predict the class of the unlabeled instance, right. Looking at the attributes, the model should be able to classify the particular instance. And there should also happen, this prediction exercise should also happen at a very fast response time. So a good model will predict the class accurately in the minimum amount of time. Another, purpose which is served by the classification model is that it can be used as a descriptive model. Now descriptive model means that it will identify the characteristics that distinguish instances from different classes. Now this particular thing, that is, it should not just tell you that this object or this instance belongs to this class, it also has to justify that why this object has been put in a particular class. This thing is very important when we are talking about the medical diagnosis. In medical diagnosis, it is not just sufficient that the model will predict saying that this is the disease or this is the reason. It also has to justify that how it has reached such a decision. So in that case, we need both the purposes, that is, the model has to predict the class and it also has to describe, or it also has to justify how that class has been predictive. So this model, the classification models, will be used in both ways, as a predictive model as well as a descriptive model, right? So if we look at the same example that we were looking at of the vertebrate classification, so this model can be used. So if we have all the attributes of a given vertebrate or of a given instance, then looking at the different attributes, it will define the class, right? So it will see that what is the body temperature, it is cold blooded, okay, it does not give birth, so it is not a mammal, and likewise it will look at the different characteristics and it will assign a class label to that particular object, right? So all attributes may not be relevant to the classification task. Sometimes some elements are relevant, some attributes are not relevant. So the key elements or the key attributes according to which the class labeling has to be done need to be identified. Now using this classification model as predictive or descriptive, so the attributes which we are not using, or basically those attributes which will not be able to distinguish the class by themselves, and thus they will be used in the concert with other attribute. So that attribute is like not a defining attribute. So what is done? An optimal combination of attribute which will best discriminate the instances from the different class is the key challenge. When you are building a classification model, it is very imperative that the right combination of attributes is found out, so that the best possible results of classification problem can be given. Because if you will use the incorrect combination of attributes, then sometimes there will be a lot of error in the prediction, in the class which is going to be predicted, because you are not looking at the right attribute to define or to distinguish the instance of one class from another class. So we need to understand the general framework of the classification model. So basically, what is classification? Classification is the task of assigning labels to unlabeled data instances. Okay, and a classifier is used to perform such a task. So we have a data set in which we have multiple instances, and each instance is actually having a set of attribute, right? Now this set of attributes will be used by a classifier to label that instance as belonging to a particular class. Okay, so therefore classifier is basically described in terms of a model, right? And the model is created using a given set of instances which is known as the training set, okay, which contains attribute values as well as class labels for each instance. Okay, so in the model, because this is the classifier actually is later on going to be developed into a classification model. So when it is a model, you need to train the model. So first what we require is, we require a set of instances which we call as the training set. Now in this training set, we have certain attributes of the instances, okay, and for each instance we have defined the class label, that is the class identifier has also been given, so that the system learns to identify, or the system sort of understands the relationship between the set of attributes and the class label. Now this systematic approach for learning a classification model given a training set is known as a learning algorithm. Okay, so we are using a training set and we are making the system learn the classification. Okay, we are training the system in classifying the object using an algorithm called the learning algorithm. And the process of using a learning algorithm to build a classification model from the training data is known as induction. Okay, so these terms are actually very important. What is a training set? A training set is that data which is given to the system for training or for using it as a learning tool, right? And the systematic procedure is known as a learning algorithm, right? And induction is the method, or it is the process of using the learning algorithm to build the classification model. Okay, so you have the classification, the learning algorithm, you have the training data. Now using these algorithm and data, you build a model, and this is known as an induction process. This is known as the induction process. It is also sometimes called as the learning a model, or it is also called as building a model. So you are actually building a model using your training set and your learning algorithm. Right. Now what we are doing in the next step, we are applying the classification model on unseen test instances to predict their class label, and this is known as deduction. Okay, so deduction means that you have created the classification model now, right, using the learning algorithm and the training set, and then you are using this model which you have developed to predict the instances of unknown data. Okay, predict the classes of unknown instances, right? That is known as deduction, which is a real task which the classification model has to do. So basically the process of classification will involve two steps. The first step will be to apply a learning algorithm to the training data to learn a model, and the second step will be to apply the model to assign labels to unlabeled instances. Okay. So first thing is that you create a model, okay, and you train that model, right, and second is that you use the trained model for assigning class labels to the unlabeled instances. Okay. Now this entire process, this general framework has been explained in this diagram, where we are saying that there is a learning algorithm, okay, and there is a training data set. Now we can see that in the training set the class identifiers have been given. Okay. So using the learning algorithm and the training set, the induction process is being done. Induction process means that we are making the model learn, we are actually creating the model. Now once we have the model created using the learning algorithm and the training set, then using this model we are going to use it for predicting the class of unknown data set, which is actually the test data. So we are working on two data sets. One is the training set, and second step we are using actually the real data, or what we call as the test data. So in induction we build the model, and in deduction we apply the model, or we actually use the model to predict the class interval. So a classification technique basically refers to a general approach to classification, right? That is, for example, the decision tree technique. This classification technique, like most others, will consist of a family of related models and a number of algorithms for learning these models. So we are going to, look at different techniques which can be used for classification, right? Like the most important and the most widely used technique is the decision tree technique, right? And in this, further using the technique, several models have been built and several algorithms have been developed for learning the models. Okay, so the terms basically classifier and model are actually used synonymously, because we are saying that classifier is actually going to be developed in a model. So if a classification technique, it builds a single global model, then it is fine. However, while every model defines a classifier, not every classifier is defined by a single model, right? Because a classifier can borrow from several models, right? So some classifiers, such as the k nearest neighbor classifier, is not built on an explicit model. It borrows from different models, right? So these terms, although they are used synonymously, but they need to be understood in a proper context, that that every model which is defining a classifier, okay, but not every classifier is defined by a single model. It can be defined by more than one model also. So the term classifier is often used in a more general sense to refer to a classification technique. Thus for decision tree classifier we refer to as decision tree classification model, okay, or decision tree classification technique, right? So it's very imperative that these terms become very clear, that what is a classifier, what is a classification technique, and what is a classification model to be understood, right? So in general framework that we have seen, we have induction and deduction steps which need to be performed separately, right? You train the model first, you build the model first, and then you apply the model for your test instances, right? So training and test are independent of each other, so that to ensure that the induced model can accurately predict the class labels of instances that it has never encountered before. So actually the set of data which is being used for training the model should not be used for testing the model. Only then we will be able to ascertain the right kind of the way in which the actual quality of results which the model is generating, the accuracy of the results which the model is going to generate. So the models which deliver such predictive insights, they are said to have good generalization performance, okay, because they work, their accuracy of prediction is very high, and the performance of a model, that is a classifier, it can be evaluated also, right. So how do you evaluate it? By comparing the predicted labels against the true labels of instances, right. So this information of, you know, the correctness or measuring the accuracy of the model, this can be done using a confusion matrix. So we will continue with our discussion on the confusion matrix in the following lecture. Till then, please keep watching CEC. Thank you.